Hello aviation enthusiasts, and welcome back to the channel. Today, we're diving deep into the nervous system of modern aircraft. The avionics diagnostic interfaces. If you've ever wondered how technicians troubleshoot the complex electronics that keep a plane flying straight and true, you're in the right place. These interfaces are the secret keys to understanding everything from the autopilot to the radios. So, what exactly are we talking about? Imagine a universal translator for all the high-tech gear in the cockpit. That's essentially what these diagnostic interfaces do. They are specialized ports and software that allow technicians to plug in and communicate directly with various avionics systems. Think of it like the OBD to port in your car, but for multi-million-dollar aircraft systems. It's the gateway to the digital heartbeat of the plane. Let's start with one of the most critical systems, the autopilot. When an autopilot isn't behaving as it should maybe, it is not holding altitude correctly or is making jerky. Corrections technicians, do UNT just start swapping out expensive parts? First, they connect to the diagnostic interface. This allows them to see real-time data from the autopilot's computer, check its commands, and review any fault codes it has logged. They can see if it's receiving proper inputs from the flight controls and sensors, helping them pinpoint the problem with incredible precision. Next up, communication and navigation systems. This includes your radios, transponders, and GPS navigators. If a pilot reports that they can't hear air traffic control clearly, or their transponder is UNT sending the correct code, the diagnostic interface is the first tool out of the box. Technicians can use it to test the radio's transmission power. Check the transponder's SADATA output and verify that all the wiring and connections are solid. This helps them identify if the issue is a simple software glitch, a configuration error, or a genuine hardware failure, saving a ton of time and guesswork. Now for the real brain power of the aircraft's flight instruments, the AHRs and ADARs. That stands for Attitude and Heading Reference System, and Air, Data and Attitude Heading Reference System. These are the black boxers that tell the pilot which way is up, how fast they're going, and what their altitude is. They combine data from gyroscopes, accelerometers, and magnetometers. If the attitude indicator on the screen looks wanky or the heading is off, the diagnostic interface is crucial. It allows technicians to perform calibration procedures, check the raw sensor data, and diagnose internal faults within these highly sensitive units. Similarly, the interface is vital for the pedostatic system. This system uses air pressure to determine airspeed, altitude, and vertical speed. If a blockage occurs in a pitot tube or a static port, say, from an insect or ISTA, readings will be wrong, which is extremely dangerous. By connecting to the diagnostic port, maintenance crews can run tests that simulate different air pressures and see if the system responds correctly. This helps them find leaks or blockages in the lines without having to physically inspect every inch of plumbing. The real power of these interfaces is their ability to identify communication errors. Modern cockpits are a network of interconnected computers, all talking to each other over data buses like a Rank 429. If one component stops talking to another, it can cause a cascade of failures. The diagnostic interface acts like a network analyzer, showing technicians which systems are communicating and which are silent. It can see if data packets are getting lost or corrupted, leading them straight to a faulty wire, a bad connection, or a failing computer. This is invaluable for troubleshooting those mysterious, intermittent problems that can be a nightmare to solve otherwise. In summary, avionics diagnostic interfaces are the unsung heroes of aircraft maintenance. They are the essential tools that allow technicians to look under the digital hood and accurately diagnose problems with the autopilot. Radios, transponders, HRS, and pedostatic systems. By helping to identify communication errors and calibration issues, they ensure our skies remain safe and our aircraft operate at peak performance. It's a perfect blend of hardware and software that keeps the complex world of aviation flying smoothly. Thanks so much for watching. If you found this look into aircraft maintenance interesting, be sure to hit that like button and subscribe for more deep dives into aviation technology. Fly safe, and we'll see ya in the next video.